All right, so a couple of units ago, you learned how to do the mole mass conversion, where you convert from moles of one substance to grams of that substance, or the other way around, where you convert from grams of a substance to moles using the formula mass. Now we have to know how to do a few more. We have to know how to convert moles and volume. In mole volume conversions, we'll convert between moles and liters, our metric base unit for volume. This is a type of conversion that is done exclusively with gases. Gases are very unique substances. Gases are mostly empty space. The particles that are in a gas are so far apart they don't interact with each other, so there's no attraction or repulsion between the particles. This means its volume is derived entirely by outside influences. It's determined entirely by almost entirely anyways, by the outside world. In particular, it's determined by temperature and pressure. What we know about gases is that at STP, and STP stands for standard temperature and pressure, it is 0 degrees Celsius and 1 atmosphere of pressure. At STP, 1 mole of any gas is equal to 22.4 liters of that gas. And again, it's completely independent of what the gas is. It doesn't matter if we're talking about carbon dioxide gas, water vapor, chlorine gas, nitrogen gas, hydrogen gas. It's always the same. At standard temperature and pressure, 1 mole of gas equals 22.4 liters of that gas. If the temperature or pressure changes, then the volume is going to change along with it, and that's something we're going to learn about when we cover gas laws. You'll know you'll be doing a mole volume conversion whenever there are liters involved in the question. So if I wanted to convert 17.5 liters of oxygen to moles, if the question said that, because it's got liters in it, I know I'm going to be doing one of these mole volume conversions. And I know my equivalence for that conversion is going to be 1 mole of oxygen equals 22.4 liters of oxygen. Now this is just dimensional analysis. That's all stoichiometry really is. It's a bunch of unit conversion. And we do all of our stoichiometry, all of our dimensional analysis the same way. We start with what we're given, 17.5 liters of oxygen. And then a time sign, and then our conversion factor. That fraction, that conversion factor's job is to cancel out the liters of oxygen, the unit we're given, and give us the unit that we're asked for, moles. In order to cancel out these liters, because they're in the numerator over here, we have to put them in the denominator over here. So when we take this equivalence and turn it into the fraction, in this particular problem, we'll put the 22.4 liters on the bottom, and we'll put the 1 mole of oxygen on the top. And again, it's all about unit cancellation. Liters of oxygen in the numerator, liters of oxygen in the denominator will cancel out. And the only unit left in the problem is moles of oxygen, which is what we were asked to find. This is 17.5 times 1 divided by 22.4. When we enter it in the calculator, we can ignore the times 1 part and just do 17.5 divided by 22.4. And that is 0.781. Calculator does give a larger number as my answer, but because I don't know, what classes and all will be looking at this, I'm going to use significant figures in my rounding here. I started off with 3 significant figures, so I ended with 3. If you're not using significant figures in your particular class, you could round that wherever you wanted to. I'll write the whole thing down. Let's take a look at an opposite conversion. will convert 2.78 moles of carbon dioxide to liters. Again, anytime liters comes up in one of your questions, you know you're doing a mole volume conversion. And the equivalence is always the same for a mole volume conversion. 1 mole equals 22.4 liters. We'll just use carbon dioxide in there as our substance this time. Process is still the same. When we do these conversions, we always start with what we're given. And I was given 2.78 moles of carbon dioxide. And again, it's times and a conversion factor. For the conversion factor, we're going to use those two numbers again, just like we did up here. But this time, I was given moles, and I need to cancel those moles out. So I'll put the 1 mole of carbon dioxide on the bottom. I'll put the 22.4 liters on top. Moles of carbon dioxide will cancel out. All I'll have left is liters of carbon dioxide, which is what I was asked to find. So this is 2.78 times 22.4 divided by 1. And again, we can ignore the divided by 1 part. So we punch in our calculator 2.78 times 22.4. Again, the calculator spits out a bigger number, 62.272. I will use significant figures on this because other classes will be using significant figures on this. And I will write 62.3. Again, I had 3 significant figures when I started, so I'll maintain that 3 significant figures when I end. A conversion factor is always considered to be exact, so we ignore it when we're doing our significant figures in the end. Well, there you go. That's the mole volume conversion. I think it's a lot more straightforward than a mole mass conversion because the equivalence is always the same every time. There's no calculating a formula mass or anything like that. It's always 1 mole equals 22.4 liters.